Hi students, in this session we are going to discuss about operational amplifier. Last session we discussed about power amplifier. Here the operational amplifier is otherwise called differential voltage amplifier. It is otherwise called differential voltage amplifier. It is a voltage amplifier. It is called differential voltage amplifier. We will see why it is called a differential voltage amplifier. This is a symbol of operational amplifier. It has two input terminals. One is non-inverting terminal and other one is inverting terminal. It means that in the non-inverting terminal, if you are giving input like this, so in the output side, we are getting the amplified version of this signal output. In an inverting terminal, if you are giving an input like this, in the output side, we are getting the inverted version of that input signal, amplified version, and the inverted version of the input signal we will get. Why it is called a differential amplifier? The voltage applied in the inverting and non-inverting, that is voltage difference. That difference is amplified in here. That's why this is called a differential voltage amplifier. It has two power supplies, positive power supply and negative power supply, and one output. This is a symbol of operational amplifier. Next, we will see the pin diagram of how it is look like really the hardware. It is an integrated circuit, that's IC. So it has 8 pins. The pin 1 is called offset null. At the same time, pin 1 and 5 is called offset null. In pin 2, we are giving an inverting input. Pin 3 is a non-inverting input. And pin 4 is a negative power supply. And pin 7 is a positive power supply. And pin 6, we will take a output. Pin 8, there is no connection. This is about the pin diagram. This is a practical hardware available. Looks like this. Next, we will see the equivalent circuit of a operational amplifier. What is equivalent circuit? See here, there is an input impedance, output impedance. Here the voltage follower, that is voltage gain is represented here. Then output, positive supply, negative supply. This is a equivalent circuit of a operational amplifier. In our syllabus, we are having the topic, the comparison of ideal amplifier versus practical amplifier. What is ideal person? A perfect person is an ideal person. Is it possible to see the ideal person? It's not possible. So here we discussed if the amplifier is the ideal one, what are the parameters it has? Then if it is a practical amplifier, what are the parameters it has? So we will discuss, we will compare and discuss about the ideal and practical operational amplifier. See, before going to that, these are the parameters related with the operational amplifier. What are the open loop gain, input impedance, output impedance, offset voltage, bandwidth? This is CMRR is nothing but common mode rejection ratio. Common mode rejection ratio. It means that how it remove the unwanted signal from the input. Then slew rate. It is how will be the output for the step input. Then power supply rejection ratio. These are the parameters related with the ideal operational amplifier. These are symbol associated with that. So what is the open loop voltage gain for the operational amplifier? It is value is infinitive. So we can simply voltage gain as AV equal to V out by V in. This is the gain formula. What is the input impedance? R in. How the input impedance value is infinitive? Actually, in the ideal operational amplifier, we have two assumptions, that is V1 equal to V2. V1 equal to V2 and the current I1 equal to 0 and also I2 equal to 0. Both current I1 and I2 equal to 0. Okay. So see, come to the input impedance. We know the Ohm's law, V equal to IR. So R equal to V by I. So we know that the output current is, the input current is V in by I in. R in, input impedance R in equal to V in by I in. We know that input current equal to 0. So that anything by 0 equal to infinitive. That's why this infinitive. Then output impedance. So we also have other assumption that V1 and V2 equal to same, and also it is equal to, in ideal condition, it produce, there is no output, V out equal to 0. In ideal condition, the output of that amplifier is equal to 0. Come to that point. Output impedance R out equal to V out divided by I out. We are not talking about the output current. So we are talking about V out. Here V out value is 0. 0 by anything 0. Then what is the offset voltage here? The offset voltage is the voltage difference between the terminal. We are giving two terminal, the voltage difference between the inverting terminal and non-inverting terminal. And the other parameter is offset current. What is offset current? Offset current is the current flow difference between the inverting terminal and non-inverting terminal. Another one current is the input bias current. It is also one of the electrical parameter, input bias current. This is the average flow of current in the input terminal, and that is inverting terminal and non-inverting terminal. Here, next one is bandwidth. What is bandwidth? If you are talking about the bandwidth, it has infinite bandwidth. It means that if the input frequency, it has, what is frequency? Actually, what is frequency? That is a inverse of, there is a relationship between the time and frequency, T equal to 1 by F. So F equal to 1 by T. The inverse of time equal to frequency. It means that some circuit allows only the 10 kilohertz to 10 hertz to 10 kilohertz like frequency one day. But these say amplifier allow whatever the frequency, 1 hertz to infinity, lakhs and 2 lakhs or 8 to 100, 200, any frequency it will allow. The input frequency is any maybe. Okay, that's why this frequency bandwidth is called infinitive. So these two things we will discuss later. And also these three things we will discuss later. This is about the ideal operational amplifier characteristics, and also this is about the parameters involved in the operational amplifier. Next, we will see, compare the ideal operational amplifier with the practical operational amplifier. So we know that we compare, that is, we discussed all the parameters value in the ideal operational amplifier. When you're talking about the input impedance, it is an infinite value, but in a practical case, it is not a infinite value. It is in a mega ohms. It is in some mega ohms. If you're talking about the output impedance, it is a 0 in a ideal amplifier, ideal operational amplifier. But in a practical case, it's in a few ohms. In a CMMR value is infinite in a ideal operational amplifier, but here in a practical cases, its value is between 60 dB to 90 dB. In ideal cases, the gain value is also infinite, but in a practical, it is very high gain value. When you are talking about the zero input current and offset voltage, so here in a practical cases, it's some few amount of current is there. And if you are talking about the slew rate, so it has some slew rate. And if you're talking about the gain, that is bandwidth, it is infinitive. But in a practical case, it has some limitation. This is about the comparison of ideal amplifier and practical amplifier. In the next session, we will discuss about the application of the operational amplifier. Thank you, guys. There is a summary of this session is what is operational amplifier and what are the practical symbol for this one, and then that is pin diagram for the operational amplifier. Then what are the parameters involved in the operational amplifier? Then the parametric value for the ideal amplifier. Then comparison of the practical amplifier and ideal amplifier. Next class we will discuss about the application of the operational amplifier.